Hey there, welcome back. This is once again an extremely important lecture because we're going to talk about CSS architecture and how we should think about layouts and how we should mark up our code in a professional way. So this one is technically not about how CSS works, but it still made sense to put it here in this section. So remember that we want code that is clean, modular, reusable, and that makes it easy to add more and more features to our web page or app if it needs to grow. So because of all of these reasons, we cannot just dive into a new project and leave architecture behind, just as a second thought. Instead, we need to take important decisions concerning our HTML and CSS code right from the beginning of the project. And that's what I want to help you with in this lecture. So we need a good strategy here, a good mindset. And from my experience, the best strategy is something I like to call the think, build, architect mindset. We need to think about the layout of our web page or web app before we actually write the code. After having the layout figured out, we should build it in HTML and CSS with a consistent structure for naming our classes. Also, at the same time, we should create a logical CSS architecture by using multiple files and folders. So, starting with the think part, I like to use something called component-driven design, which is actually a principle that is used across all software development. In CSS, with component-driven design, we try to divide our page into modular components. So, what are these components? Components are the building blocks that we use to construct our interfaces. So we can basically think of our interface as a collection of components, held together by the overall layout of the page. Probably the most important thing about components is that they should be reusable across a project and also between different projects. That's really important. So you can build a library of your components and then reuse them across projects, which will speed up your development. Plus, components should be independent so that we can use them completely on their own, no matter where on the page. What this means is that components should not depend on their parent elements. Once again, all of this will make your CSS code easier to maintain and to scale if necessary. Now, of course, these are rather general rules, and they can be broken if it's strictly necessary, as long as you have a good reason. Now, I don't want you to memorize anything here, okay? This is just a discussion that we need to have in order to become better CSS developers. Over time, with practice, all of this will become really intuitive to you. And of course, we're actually going to apply this in a Naders project that we already started coding. Alright, and just as a side note, this whole thinking component strategy is actually a bit similar to Brad Frost's super popular atomic design philosophy, which maybe you have heard of by now. So according to atomic design, the smallest units on a page are atoms, which together form molecules, which combine together form organisms. And these organisms can be seen as our components in some situations. Now, we're not going to focus so much on atomic design in the course though. I just wanted to let you know that there are other ways of thinking about our interfaces. And you can take a look at atomic design if you're interested and if you haven't heard about it. Alright, so after thinking about our design, we need to code that design using HTML and CSS. And in this step, it's important to have a consistent strategy, a structure for naming our classes. And there are many approaches for naming classes. Things like object-oriented CSS or SMACs, but the one I like the most is BEM, which is becoming more and more popular by developers around the world. It's a nice clean system for marking up our layouts. So, BEM stands for block, element, modifier. And this is how class names usually look like using the BEM methodology. So, if you've ever seen code that looks like this example here, now you know that it uses the BEM system. So first, in BEM, a block is a standalone component that is meaningful on its own. And what this means is that the components we defined in the last slide are the blocks in BEM. In this example, the recipe is a block and also the button, because both of them are standalone components that can be reused anywhere in the project. And note how these two blocks are actually nested. So the button block is inside the recipe block. And that's perfectly normal and acceptable. Next, an element is a part of a block that has no meaning on its own. So in our example, That could be the info panel or the stats box, but there are lots of other elements there. But again, if we take one of these elements out of the block, then they wouldn't be useful at all. They wouldn't have any meaning. Now what's important to note here is how the recipe block still appears in all the class names within the block. Do you see that? That's why we have the word recipe all over the place in this HTML code. Also, notice how this creates selectors with really low specificities, because we always use classes and they are never nested, and so they always have a pretty low specificity. And this is one of the big reasons why BEM is so widely used for easy to maintain and reusable code. Alright, and last we have the modifier. And the modifier is a flag that we can put on a block or an element in order to make it different from the regular blocks or elements, to make a different version, let's say. In our example, we have a modifier to make the button round. So for instance, there may be some rules for all buttons, and then we use a modifier to make a more specific, a different button, and in this case, a round one. Now try to read that entire HTML markup I just showed you, okay? Seriously, try to stop the video and read the code. Because just by reading the markup with these class names in it, you can instantly see how all the elements are related and what each of them does. Now imagine this with a whole page, and the effect would become even better. Now again, you're gonna get used to all this once we start using it in practice throughout the project, in one of the next lectures. Alright, and just to finish this part, I know that many people really hate BEM because they say it looks ugly and it's hard to write. And yeah, I agree that it might look a bit funny actually, and that you might have to type a bit more code. But believe me, that is really worth it. And you should absolutely try it with me once we start coding again. And now the last part of our strategy, which is architecting CSS. And remember that by that I mean to create a logical folder and file structure for our CSS to live in. Once again, there are different options here, like the itCSS method or SMAX, but I like to use something called the 7-1 pattern, introduced by Hugo Giraudoux. I'm not sure if I spelled his name right, but let's hope. Okay, so the 7-1 pattern is extremely simple. All it means is that we have 7 different folders where we put partial SAS files, and then one main SAS file in which we import all of our partial files into one final compiled CSS style sheet. Of course, when I say SAS here, I could mean any other CSS preprocessor, because all of them allow to implement pattern, okay? And we'll see how that works in practice once again a bit later. So the 7 folders I mentioned that are used in this method are the base folder, where we put the basic project definitions, the components folder, where we have one file for each component, the layout folder, where we define the overall layout of the project, the pages folder, where we have styles for specific pages of the project, the themes folder, if we want to implement different visual themes, the abstracts folder, where we put code that doesn't output any CSS, such as variables or mixins, and finally, the vendors folder, where all third-party CSS goes. So that's just a big overview, but I'll go into further details about these folders once we really implement them in the project. Now, we don't always need to use all of these folders, and that's gonna depend on the size and the scope of the project. Alright, and that's it about CSS architecture, BEM, and component-based design. I hope this made sense to you, and that you can see and appreciate the huge value that these techniques can add to our workflow. I'm sure that putting this into practice will help with that. So stay tuned for the next lectures where we're gonna do exactly that.